Okay, so in this video, we are going to look at algebraic fractions. I think you've interacted with fractions and you know what fractions are. It's when you have a numerator and a denominator. Okay, so in this case, when we talk of algebraic fractions, we simply mean instead of just having the normal numbers, as we know in normal fractions, we have something like a half or 3 over 5 here. In this case, we have an algebra being included in part of the fraction. For instance, we can have something like 3x over 5, or you can have something like x over 2, or even we can have something like 2 over x. All of this qualifies to be algebraic fractions. Okay, and now whatever we want to look at, we want to look at the manipulation or the operations that we can carry out whenever we are dealing with algebraic expressions. And I want to use the following example to help us understand or to help us go through it. When we talk of algebraic fractions, we deal with the following operations rather, that is multiplication and division. How do we handle algebraic equations on multiplication and division? Okay, let me use this example. We have an example here, that is x squared minus 7x plus 12 all over x squared plus 3x minus 28 times x squared minus 49 over x squared minus 9. Okay, so that is the question, and I've decided to use multiplication because even if we are having division, it will eventually turn to multiplication. I believe we recall that, yeah, the basic math of division. So it eventually comes to multiplication. So that's why I'm using the multiplication in this case. So whenever you have a question like this, the first thing you need to do, because when you try looking at these fractions, or the one on my left side and the one on the right hand side, like you can literally see there's nothing that can be cancelled out or that can be simplified. So whenever you have a quadratic expression in an algebraic fraction, the first step you need to do is to factorize them. That is the first thing. So we need to factorize all the quadratic expressions we have. So let me begin with the first one, x squared minus 7x plus 12. Okay, I need to factorize this, and let me use a different color. Okay, so for us to be able to factorize this, I'll use the product sum rule. Okay, whereby the product sum rule, we understand we take the coefficient of x squared multiply with c, of which in this case the coefficient of x squared is 1 and our c, this is our a, this is our c, is 12. So when I have 1 times 12, I'll have 12. Then I get the factors of 12, okay, which when I add will give me negative 7. That is where the product sum rule comes in, okay. So the product of those factors will give me the 12, but the sum of the factors will give me negative 7. Okay, so the factors I have is 6 and not 6 and 2, but some of the factors I have is 6 and 2. But 6 and 2, whatever I do to 6 and 2 can't be give me negative 7. Okay, so that means I'll go for the second pair factor, which is 4, 3. Okay, and 4, 3, from the look of things, there's something I can do to 4 and 3 to give me negative 7. I make all of them to be negative, such that when I take negative 4 multiply with negative 3, I'll get positive 12, and at the same time, the sum of them will give me negative 7. So that is the product sum. So when I replace them, I'll have x squared minus 4x minus 3x plus 12. Group them into 2. The common factor in the first bracket is x, so I'll remain with x minus 4, minus the common factor in the second bracket is 3. When I factor out, I'll have x minus 4, okay? Because this positive, it changes to negative, because whenever we are factoring out, it's like dividing with the common factor. This is positive 12. When you take positive 12, divide with the common factor, which is negative 3. What will I get? I'll get negative 4. So be keen whenever you are factorizing a negative factor or a negative number. Then the factors outside the bracket, we put them in one bracket, that is x minus 3. Then the other two similar factors, I choose one of them because they are the same. Okay, good. So we move to the second part, or to the second quadratic expression. That is x squared, sorry, that is x squared plus 3x minus 28. Okay, I do the same, I factorize. Okay, and at this point, since I know a is 1 and my c is negative 28, I know when I multiply them, I still have negative 28. Then I look for the factors of negative 28 that will give me positive 3 when I add. Okay, first of all, the factors of negative 28 is 4 and 7. What do I need to do to these two to give positive 3? That means I need to subtract 4 from 7. Okay, and when I multiply, I'm still getting the negative 28. So I'll have x squared minus 4x plus 7x minus 28. Okay, once I do that, group them into 2. What is in the common factor in the first bracket is x. I remain with x minus 4 plus in the second bracket, common one is 7, whereby I get x minus 4. Then take the factors outside the bracket, put them as 1. Then since the other two are similar, we just pick one of them. So we factorize that as well. Okay. Next, we move to the third part of the quadratic expression, which is x squared minus 49. We need to factorize this. One thing you need to know, this kind of quadratic expression is known as the difference or the difference in two squares. Okay? Whenever we talk of two squares, these are factors, they are rather terms that you can easily get their square root. Like we can easily get the square root of x squared and the square root of 49. Those are what we call the difference in two squares. Whenever we have such kind of expression, the factors, okay, or when you factorize it, you get their square root, that is x squared, which is x, and 49, which is 7. Then to be able to get the factors, one of them will be a positive, the other one will be a negative. So it's x minus 7 and x plus 7. Okay, we move to the other term or the other expression, which is x squared minus 9. We do the same, we factorize. And when you look at these two terms, you can easily get their square root, right? So that simply tells you that they are difference of two squares, okay? Which is 3. So the factors becomes x minus 3 and x plus 3, okay? Once you've done that, we now resubstitute them back into our original question from here, okay? So this is what I'll have. Now I'll have, let me use the black one. So now I'm having x minus 4, x minus 3 over x minus 4, x plus 7 times x minus 7, x plus 7 over x minus 3, x plus 3. Then at this particular point, we cancel out the like terms. Okay? Anything that looks alike to something that can easily cancel, we do away with it like that, and that will cancel. X power 7, x plus 7 and x plus 7 will cancel. X minus 3 and x minus 3 will cancel. So when that happens, what do I remain with? On the left hand side, everything has been cancelled. I only remain with something on the right hand side, which will be x minus 7 over x plus 3. That becomes your final answer. Okay, so that is how we handle multiplication and division of algebraic fractions.